are that x has to be greater than or equal to 0, maybe, and y has to be greater than or equal to 0. All right, so here's our little graph paper they gave us. We already know x greater than 0 means it's to the right of this line. Y greater than or equal to 0 means it's above the x-axis. What are the other two equations? Somebody read one of them. The one about the wheels. What did that say, guys? Okay. I want to revisit what we did the very first day of class. We talked about if I put a 0 in here, 4 times 0 would be 0, plus 6y equals 360. Can you solve that in your head? 60. So when we put in a 0, we got out a 60. I'm trying to give us an easy way to find the intercepts. What would the other intercept mean? Put a 0 in back here, so then it would say 4x equals 360, which would be, so that one was 90, 0. Do you remember doing that? Okay. Could you solve it for y equals form and graph it? Absolutely. Okay. But it's not necessarily efficient use of our time because we might need those intercepts anyway. Okay, over 0 up 60 is here, over 90 up 0 is here. I'm going to cheat and use my line tool. Yes? Do you have a ruler that Jared passed out for me? Okay. Are we talking about above or below that? We have only enough wheels for that, right? So we need to stay below that. All right, I need the other equation. Can anybody help me remember the other equation? Okay, if x is 0, this will simply say y equals 100. So we have 0, 100. If y is 0, it'll say 2x equals 100. Nice. Okay, can you plot that and draw that line? Above or below that one, guys? Now, do you remember when you did this on the quiz last Friday? The final answer is the part that's double shaded. Okay? We have to be really careful on these today. Below both lines would be bounded up to this dot, down to here. That looking okay to everybody? Absolutely. Yep, you can wait till the end and figure out which area works. But fifth hour, on their exit slip, I asked them about questions they had, and some people had questions about the boundaries of the area. So we have to be really careful that we figure out the specific area because we want the corner points of that, what's called feasible region. The corner points don't include this guy out here. Can anybody give me a practical reason for this problem, why 0, 100 won't work? Look at what we wrote down. Okay, but we could make 0 cars. But could we make 100 trucks? Why not? We don't have enough wheels, okay? So it's outside of our boundaries. So we need these points that are on the boundaries. What are the ordered pairs? Somebody give me this one. 0, 60. Thank you, Morgan. Anybody got the corner down here? That's a tough one.
0.
Nice. Who's got this guy? 50, 0. Now this is the one, you guys probably have it nicely because it's graphed better using your ruler than my silly lines. But this is the one students struggle to find because you have to find the solution to where these two lines intersect. I could solve them for y equals, put it in my calculator, find the intersection point. I could solve by substitution. I could solve by elimination. What did we learn the last couple days? Matrices. Can I put in the matrix 4, 6, 360 and 2, 1, 100 and do what? When I put it all in one matrix, we use RREF. Nicely done, guys. Try that. I know you guys can tell on your paper, but we're going to need this later today. Okay, second matrix. Over to edit. What size is it? 2 by 3. Do I have it in right? Okay. 4, 6, 360, 2, 1, 100. Then where do we go to find the second part? Yeah, you have to quit. Whoever said you don't have to quit yesterday. This one, yes. Sometimes you might not have to, but this one you do have to quit. Then go back to matrix, but where are we going this time? Math. Yeah, I usually go up. Got to find RREF. Some of you like to find B. And then we have to put the name in. Back to matrix, and I stored mine in. Actually, it's in both A and B because I did it wrong earlier. Okay, what two equations does this represent? The top row reads x plus 0y equals 30. In the bottom row, y equals 40. So do you understand what we just found? Yeah. Oh, I didn't mean to close that, but I think I did close it. I don't know. Doesn't matter. What's this ordered pair then? 30 for x and 40 for y. Did everybody already have that? Because it graphed nicely on yours, better than mine. Okay, you guys are just better than me, that's all. Okay, what's going on here is we need to use what's called the objective function to find out something about the profit. The maximum or minimum profit or cost or whatever we're dealing with will always occur at a corner of our region. So list the corner points again for me. 0, 0, 0, 60, 50, 0, and 30, 40. Okay, excellent. Okay, read this sentence and somebody tell me what I'm going to write for the profit expression. Profit is equal to how much? $1 for every car and $1. That would be not very exciting. But if we only made $1 for every profit for every car and every truck, what would this yield? Putting a 0 in for X and a 0 in for Y would give me a whopping $0 of profit. What about this one? 60, 50, and 70, because they're all just X plus Y, right? For that particular one. So our maximum profit would be how much? Yes. $70 if we make what? Everybody all right with where she got that? 30 cars and 40 trucks. All right. I want you to do this one for me. Do you have room to do a little scribble work at the bottom of that page? It's little. What would this expression look like? What if I totally change the scheme of things? I up my prices and I'm going to charge an extra so that I make a $2 profit on a car. That would be what? 2x. I'm going to make a $4 profit on every truck. Okay. You need to plug each of these ordered pairs in and figure out how much you'd make. Well, guess what? 0, 0, I'd still make 0. What if I put in 2 times 0 plus 4 times 60? Okay. 50, $2 times $2 each plus 0, 4 would be 100. What am I missing? The 30, 40? 30 times 2 plus 40 times 4. 60 plus 160 is 220. Okay, what happened?
We make more money with 60 trucks.
We made the most money at... Okay. That was another question. We did this question 5th hour, but yet on the way out, the exit ticket, they asked me Well, is it always where the lines intersect? Was this always in the middle at the intersection? That profit function can totally change the scheme of things. What if I said I'd make $1,000 on every car and a penny on every truck? Are we going to want to make any trucks? No. Okay, so that profit function changes the whole outlook as to where the maximum or minimum is going to be.
So it's always the corner?
Yes, and I'm going to show you the theorem for that. Perfect lead in to going back to the other worksheet. Before I go on to the slide about it always being the corners, how do you feel about some of this vocabulary now? The objective function, what else did I call it? For that question, it was the profit part of it, the profit function. Constraints, what were the constraints? Yeah, the inequalities that we wrote and graphed. Feasible solutions, the shaded area. Yep, perfect. All right, guys, this is the theorem out of the book. It says the vertex theorem for optimization. Doesn't it sound like you're really smart now you say that? Basically, it says the max or min will always occur at a vertex, otherwise known as a corner. Yes? Corner point? Okay. So basically, you're going to shade, find the corners, and use them to plug into the objective function. This is at the top of your worksheet. Worksheet number 11A. Everybody see it? Okay. I have reworded these to be today's learning targets. By the end of the day, I'm going to ask you this again. Your goal is, can you write an objective function, that's the profit one, and a system of constraints? Can you graph it? Okay. I can find the vertices or the corner points. Remember, you can graph, you can use your calculator's graphing system, you can use matrices, my favorite. You can solve by substitution and elimination. And then can you, at the end, plug all those corners in to find the maximum or minimum? Seem all right? Okay. We're going to do one that's not an application, so don't get all caught up in the fact that you might get negative numbers in here, okay? Because it's not an application. I'm going to put one like this on a test or quiz because I want to know, can you graph and find the intersection points without having to read all through the word problem? Does that make sense? Then I'll do another one, there'll be a word problem, and you'll cry. No, we won't cry. We'll be good. All right. Are those two already done for us?
Yep.
Why? What are they telling us? Yeah, they're telling us that we're in the first quadrant, right? So it's got to be above the x and to the right of the y. Okay, how do you want to do the first line? Want to do intercepts, or can we just get that one in y equals form? What would it say? Yeah, 10 minus 2 or negative 2x plus 10. So here, down 2 and over 1. Good? Where am I going to shade? This one we solve for y, and it says less than, so below. You want to get this one in y equals, or you want to do intercepts? If I put a 0 in for x, cover that up, and it says 2y equals 8. Or, if I put a 0 in for the y, it says x equals 8. Good job. Okay, over 0 up 4, over 8 up 0. I'm not using my line tool, kind of on purpose. Above or below again? How could you check since it's not in y equals form? Could you put in a 0, 0? Yep. What would it say? 0. Less than 8, it's true, so we're shading on that side where 0, 0 is. Okay, so what shape is that? Pretty. Some kind of quadrilateral, yes? That was another question asked by 5th period. Is it always 4 corner points? We're going to do one in a little bit that has 5. Someone asked, could it be 3? What if there was only one constraint? Could you make a little triangle? Yeah. Corner? Certainly. All right. Who can give me some of the corner points without any effort?
0, 0. 0, 4, 8, 0. 4, 2.
8, 0. Is 8, 0 a corner point?
No, it's not. It's
understands why though?
Because you can't pull.
Okay, it's not shaded. It would work in the blue equation, but not in the other. Right, perfect. Nice explanation. Okay. What do we have left? Okay. I could solve by elimination. I could solve by substitution. I could solve by matrix. Substitution. If we did substitution, we could put this in here for y, and it would say x plus 2 times negative 2x plus 10 equals 8. I got 4. Did anybody get 4?
Yeah.
Somebody do it a different way? Did you do the matrix? If we plug the 4 back in one of those, like right here, it'll say negative 8 plus 10, which would be, does anybody's paper make it pretty clear that it was 4 too? Okay. Don't always assume. There's even decimals sometimes, okay? But if you thought it was 4 2, could you plug a 4 here and a 2 here and a 4 here and a 2 here and check that it fit in both? Nice. All right. What do we have to do to finish?
Plug it in.
I like to make a little chart. I'll even give you a little chart on the test to help you organize your thoughts here, but the corners were 0, 0, 0, 4, 8, 0, and 4, 2, yeah, not 8, 0, 5, 0. Thank you, Kristen. Yeah, that's just a big blob, Hot Power. Nice job.
How far big dot here?
Yes, big blob on the paper. Okay, what's the expression we need to evaluate?
3x.
Okay, so start typing that in and see what you get. Weirdness. Did anybody else get a negative?
Yeah.
How'd I do? 0, 15, negative 8, positive 8? Okay. Maximum. Read the directions. What does it want?
Maximum and minimum value.
Values. So what's the maximum value?
15.
So I'm going to write max of 15, and it occurs, doesn't it also want where it occurs? And what values of x and y? So where did that one occur?
0.
5, 0? Is that what you said? I wasn't looking. Min, be careful. It's actually negative 8 this time. It's negative. So if we were to make 0, 4, whatever this was talking about, we'd end up in the hole. It's not obviously the profit.
It could be like, are there applications of this where you could get negative values like this?
Yes, depending, for example,
Like the opposite.
what would minimize something or maximize something depends what we're trying to do. Yep. You could end up at a loss. You could have a minimum value that's you're minimizing the loss. Good questions. Okay. 3 minutes. No more. Get this one done. You can talk to the people next to you. And let's do Claire. She's already done. If you didn't, all the better, honestly. Error analysis is always a better way to learn. As you all know, by analyzing all my errors. That's exactly how mine looks. That's great. Go for it. You're fine. I think my board needs to be calibrated too. How many quarters this time? We're going to do solid for all the applications because usually our constraint is right up to the limit. That was a great question. In theory, it could be you can't use all of your something, so it could only be less than, and then you have that in. But the ones we're going to do, we can just do solid. Okay. What? Oh, good, good. One more sentence looks like Claire's.
Well, if it looks like that one, then it's
Or
probably
kind
kind of a
Claire.
mess.
Does she have the corner points right? What matrix might you have used if you wanted to use one to find this point up here somewhere? Yes.
1, 1, 4.
Okay. And if you did that, you would get out 1, 0, 0, 1,
3, 1.
No, I think you're fine. I mean, as Miranda says, the Hofbauer big dot theorem says it's right at 3, 1, right? Move that dot down. Oh yeah, it's right there. I don't know. Then how did you get these values though? So 0 plus 2 times 0, 4 plus 2 times 0, 3 plus 2 times 1, and 0 plus 2 times 2. Everybody okay? All right, maximum and minimum. I think she did a beautiful job. How many of you were able to get that answer? I see you're still working. You okay with where she got those? That one, the alphabet. Yep, the smallest is the min. All right, we're going to talk about what happens if there's 2 maxes or 2 mins as well in a second here. All right, quickly moving on to an application. This one is largely done for you. I just want to talk about setting up the constraints. A leather company. Okay, story time. Who wants to read?
I'll read. All right. A leather company wants to add belts and wallets to its product line. Belts require 2 hours of cutting time and 6 hours of sewing time. Wallets require 3 hours of cutting time and 3 hours of sewing time. The cutting machine is available for 12 hours a week, and the sewing machine is available 18 hours per week. Belts will net $18 in profit, and wallets will net $12. How much of each product should be produced to achieve maximum profit?
Okay, I went ahead and told you what X and Y are. Thank you, Miranda. I always do the objective function first. I'm going to tell you why. I look at that problem, and there are so many numbers that I am kind of blown away. But I look and I go, well, this is a profit on the belt, and this is a profit on the wallet, right? So 18 per belt plus 12 per wallet. That's the profit function or the objective function. I'm done with those numbers now until the very end of the problem. That always helps me to narrow down what I need to do for my constraints, okay? Now, the 2 constraints I have are the cutting machine is only available 12 hours, right? Okay. What do we need to do?
You would need to make all of your belts and wallets in less than
Okay. And every time I make a belt, how much cutting time do I need?
2.
So I would write 2 times, okay? 3, why is it 3? Why?
3 hours.
3 hours to cut. Okay, guys, we're looking at cutting. So it's 2 hours of cutting, 3 hours of cutting, and 12 hours of cutting available on the machine. Do you see that now? It is confusing because it doesn't go, the sewing is a totally separate equation. What are we talking about for sewing? Let me call on somebody. Riley, you take this one. Is less than or equal to the 18? Everybody see where that came from then? Maximum time. Okay. This one has a funky answer. I'm not going to take time because it's done for you on your paper, but they graphed it. They did the corner points and they got a weird corner point. Again, matrices would have been really nice to find that one, right? Okay. Can you tell me the matrix I would have put in to find that?
2, 3, 12, 3, 18.
Okay. And it would have come out 1, 0, 1.5, 0, 1, 3. Okay, to find that ordered pair. Everybody clear on how that would help us? Okay. So, then they plugged into our profit. They did that for us. 0, 48, 63, 54. If it's profit, we want to maximize, yes? They found a maximum of 63. But it comes out at 1.53. But this was the number of hours available per week. So we should make 1.5 belts and 3 wallets every week. Is it possible to sell a half a belt? But if we do it again next week, will we be okay? We'll finish the belt and move on. Okay? Do you see where it's okay that it could come out a half a belt here? All right. We're going to talk about when there's multiple solutions or when you have what's called an unbounded region. We're going to do more of these tomorrow, but let me give you a really quick example. If the cost was here, the cost of something else was this way, and I wanted to minimize, or the constraints were there, and I wanted to minimize the cost, I could go infinitely large, right? But the minimum is going to occur at one of these points where it bounds. Okay? Yeah, I enjoyed that. All right, guys, but it does say it up here, all right, if it's a polygon that is unbounded, okay, it is possible it has no maximum or minimum, but it's also those points down at the bottom could be. And it says if the graph of the objective function is consistent or coincident, if it lands right on top of one side of the region, it will have multiple solutions. I think we're going to have one of those in a second. Okay, this one is also done for us because I just want to talk you through some weird situation here. 2x plus y is less than or equal to 8. They graphed it's this line in red right here. I really wanted to do this one with you because of these two equations, because you have a bunch of these kind on your homework. I love them. Y equals 4 is what kind of line? Okay, they're all straight. It's parallel to the x-axis, Besma said. It's called horizontal. Yes, guys? Y equals 4 is that horizontal line. X equals 3 is this vertical line. Guys, listen real quick. To find those intersection points, I could use substitution. Let me just show you one real fast. If y is 4 and I want to see where it crosses this line, I can just put the y equals 4 into that and solve. Does that make sense? So I subtract and divide and get 2. I put in a 4. I got out a 2, which they did. I put in a 4, got out a 2. Y equals 4, x equals 2. Thank you. Sometimes we put the x first in the ordered pair. Just when we want to get it right. Okay. So then we're going to put it in this function right here. Can you solve all those real fast? Fill in these little blanks, guys. I'm going to talk about where the maximum is. What was the maximum amount we ever got?
24.
24. But it occurred where? At 2 different places. Okay? It occurred here and here. That means every point along that little stretch is a solution. Okay? It's the maximum will occur at multiple places. It occurs at 2, 4 and at 3, 2 and all points in between. On the quiz, there's not one of those, okay? I'll tell you right now. Okay? There's one solution on the quiz or the test or the final or anything. But it is possible to have more than one place. All of the places along here would maximize the value. All right. I am going to skip this one. And we're going to do this one that has application to it. All right, we're going to make roller skates and ice skates. Ready? Okay. So do you want X to be roller skates?
Yep.
And Y to be ice skates. This will help. If you put it up here, this is X, this is Y. Guess what? This is going to get an X, this is going to get a Y. This is going to get an X, this is going to get a Y. This is going to get an X, and this is going to get a Y. Okay, I like to start with the objective function or the profit. What is the profit? Someone, let me call on somebody. Look, I have my magic sticks. Michaela, can you give me the profit function? It's that last line. Phone a friend.
30x plus 41.
Because it's just the profit and we're making 30. You good now? Okay. Cassidy, can you come up with one of the constraints for me? Maximum time, so we got to stay under that. Yep. Good call. Good call. Jacob Martin. One more constraint. We okay? Okay. Supersonic speed. Anybody tell me the intercepts of this one? If X is 0, Y will be 50, I think. If Y is 0, X will be 40. This one would be 120, 0, 30, and 120, 0. Is that going to fit? No. One of them will. The other one's clear out here at 120. Can anybody tell me what the slope of that line is real quick? Subtract X, divide by 4. Negative 1/4 though, right? So I'm just going to find a point over here. It's going off that way, but I don't really care because it's got to be under there. So, once again, we get how many dots? 4. I need somebody type it on their calculator, though, to find the intersection point because I don't think it's nice. Somebody got the... what are the other corners? Well, she's typing on her matrix for us. 0, 0, 0, 30, 40, 0, 20, 25. Thank you, Basma. Someone else get that? Confirm? Katie's typing.
2025, yeah.
Thank you. All right, what are we going to do to put it in? What are we going to put it into, those values? Okay, profit. Emerald, what's the profit if we make nothing? You're a genius. Tanner, what if we make 0, 30? If we make 30 pairs of ice skates.
1200.
Okay. And Pat, what if we make 40 pairs of roller skates? 1200 again. Anybody got this last crazy one? 1600. Thank you, Kate. So what should we do?
Make 20 pairs of roller skates and
20 roller, what was it? 25. Sorry, I lost my place. Ice skates for a maximum profit of $1,600. All right. Learning targets. How did we do? Do you feel like you can write an objective function and inequalities? Maybe. Ready to try it? You know what that vocabulary means? Feasible region, corner points, max and min. Okay. You got 2 minutes on your exit ticket. 3 foods you like. That should take you about 10 seconds because you're all hungry this time of day, right? 2 things you need to review for the pre-calc final. 2 things you want to be sure I go over on this final, before this final. And then the last one, if you still have a question about something we did today, I don't really get the corner points, I don't really get the shading thing. I like to eat everything. I want to review everything. I really didn't get anything. Yeah, I got everything. I don't have any questions. But remember, it's okay to have questions. You can leave the rulers out, pick them up. Take your exit slip at the door. Oh, one more thing I forgot. Back here by the pencil sharpener is graph paper. You want to help yourself to some graph paper. Thank you, ma'am. Does anybody need a ruler? I have like literally a grocery bag full of rulers, so if you need to take one of these home, I'm okay with that.
I'm like,
Thank you, ma'am. I love it. He's on his phone looking up his grades, so he can see which is the lowest quiz grade, and he's putting it down on there what we need to review. I love it.
That was the movie review we just did because that's our lowest grade. So, and that was just some mistakes. So, just hate when that happens. And then you gotta retake the whole thing. See, I'm not even gonna bother about retaking it because I'm still an 85 for this class, so it's not worth it.